March 4th, 14 minutes past 6 in the morning, 48 kilometers north of Fort McMurray, Alberta. The temperature on the mine floor is minus 29 Celsius. A Caterpillar 797F is at the bottom of the pit. It has just been loaded by an electric rope shovel, 3 passes of the bucket, each carrying roughly 130 tons of oil sand. The body is full, 400 short tons. The weight sitting in that steel body right now is heavier than a fully loaded Boeing 747. The operator releases the brake. The C-175-20 engine, 20 cylinders, 4 turbochargers, 4,000 horsepower, begins pulling that load up a 10% grade haul road carved into the side of the mine. The tires alone are 4 meters tall. Each one weighs more than 5,000 kilograms. There are 6 of them. The machine is 15 meters long, nearly 10 meters wide, and it is now accelerating. In the next 11 minutes, we are going inside the machines that carry Canada's mining industry on their backs. Every cycle, every shift, and every day of the year, this is the haul truck. If you enjoy watching real heavy machinery in action, bulldozers, excavators, and the machines that build the world around us, hit that like button. And if machines like these fascinate you as much as they fascinate us, consider subscribing to the channel. But we also want to hear from you. Have you ever worked around heavy machinery, operated equipment like this, seen machines like these on a construction site? Tell us in the comments. Many of the best stories in this community come from the people who have actually lived these moments. Now back to the story. But to understand how this operation unfolded, we have to go back. The Caterpillar 797 series was born in 1997, when mine operators running large electric rope shovels with 80 to 90 ton per pass bucket capacities needed trucks to match. Smaller trucks meant more trucks. More trucks meant more haul roads, more drivers, more maintenance cycles, more fuel, and a higher cost per ton moved. Caterpillar's engineers at the Mining and Construction Equipment Division in Decatur, Illinois, accepted the challenge. The result was the original 797, which entered production in 1998 with a 360 short-ton payload. The 797B followed, and then the 797F arrived at MINExpo International in September 2008, the machine that took the payload to 400 short tons and introduced the C-175-20 engine. The C-175-20 is a single-block, 20-cylinder diesel engine, quad turbocharged, air-to-air after-cooled, electronic common rail injection. It produces 4,000 gross horsepower at 1,750 revolutions per minute. The engine alone weighs more than a loaded highway transport truck. Transmitting that power to the ground requires a 7-speed planetary power shift transmission matched to a lock-up torque converter. A system that allows the truck to maintain constant power across a wide range of speeds, even on steep grades in poor underfoot conditions. The brakes are a system unto themselves. 4-corner oil-cooled multiple disc brakes, permanently sealed against contamination, continuously cooled through a water-to-oil heat exchanger. On a fully loaded 797F descending a mine ramp at 60 kilometers per hour, the kinetic energy being managed by those brakes is staggering. The automatic retarding control system prevents the operator from overspeeding during descent by automatically engaging the brakes to maintain a set speed. The tires, size 59/80 R63, sourced from Michelin or Bridgestone, stand 4.03 meters tall and weigh 5,300 kilograms each. The 6 tires on a 797F collectively cost more than most family homes. They are the single largest consumable maintenance item on the truck. And on a haul road carrying repeated 797F cycles, the road surface itself is engineered to specific standards to protect them. Caterpillar does not own this space alone. The Komatsu 980E-5SE represents a fundamentally different engineering philosophy for moving the same 400 short tons, and in some respects, a more aggressive one. Where the CAT 797F uses a mechanical drivetrain, engine power transmitted through a physical transmission and rear axle, the Komatsu 980E-5SE uses a diesel-electric powertrain. The engine drives a generator. The generator feeds AC electric motors at each rear wheel. The wheels are driven directly by electricity. The result is a system with fewer mechanical components in the drivetrain, fewer gear sets, no physical transmission to rebuild, regenerative retarding that feeds energy back into the system during descent, and more horsepower. The 980E-5 SE's 16-cylinder engine produces 4,400 gross horsepower, the highest in class among ultra-haul trucks at the time of its launch in 2023. At a gross vehicle weight of 1,400,000 pounds, slightly heavier than the 797F's 1,375,000 pounds. The 980E-5 SE operates at a top speed of 64 kilometers per hour and carries its 400-ton payload through Canadian mine sites in conditions ranging from the oil sands of Alberta to the nickel and copper mines of northern Ontario and British Columbia. The Komatsu Payload Meter 4 system, standard on every 980E-5 SE, records every load cycle, payload weight, empty carry weight, haul cycle time, speed, and fuel consumption per cycle. Mine managers use this data to optimize fleet routing, detect overloading, and calculate real cost per ton figures for every shift. The truck becomes a data source. The mine becomes a managed system. Both the 797F and 980E-5 SE are operating in Canadian mines right now. Understanding the haul truck means understanding the cycle it is part of. The load haul dump cycle, LHD, is the fundamental production rhythm of every open pit mine in Canada. Every design decision made by Caterpillar and Komatsu on their ultra-class trucks is made to serve this cycle. Every investment a mine makes in haul truck capacity is made to compress it. The cycle begins at the loading position. An electric rope shovel, the type of machine that dwarfs everything around it. With a bucket that can hold 50 to 90 tons of material in a single pass, swings its bucket and loads the truck. 3 to 4 passes typically fill a 400-ton truck body. Loading time approximately 5 to 8 minutes. The truck then hauls from the pit floor to the dump point, a crusher at the surface, a stockpile area, or a waste rock dump. Haul distance varies by mine layout, but in a deep open pit operation, haul road grades can reach 8 to 12% over distances of 2 to 5 kilometers. Haul time loaded, 8 to 15 minutes depending on grade, distance, and road conditions. At the dump point, twin 2-stage hydraulic cylinders raise the body. The oil sand, rock, or waste material slides out. Body raise time on a 797F at high idle, approximately 25 seconds. Lower time on float, 19 seconds. The truck returns empty, cues at the shovel, and the cycle begins again. An efficiently run 797F on a typical oil sands haul cycle turns around in 25 to 35 minutes. And over a 12-hour shift, a single truck can complete 20 to 28 complete cycles, delivering 8,000 to 11,200 tons of material per shift. At a mine running 20 trucks in a single fleet, that's up to 224,000 tons in 12 hours. That's why the cycle time matters. Every minute saved per cycle is multiplied across every truck in the fleet. Canadian mines are not kind environments for any machine. And ultra-class haul trucks face conditions that test every engineering choice made during their design. In Alberta's oil sands, winter temperatures drop below -40 Celsius. The 797F's cold weather package includes engine block heaters, hydraulic system pre-warming circuits, heated fuel lines, and a cab heating and defrost system rated to -30 Celsius. The tire compound itself is a cold weather formulation. Standard OTR tire compounds can stiffen to the point of fracture risk in extreme cold. The oil sand material being loaded is abrasive, silica at Mohs 7.4. Every load cycle drops 3 to 4 passes of this material into the truck body. From height. The impact loads on the body floor, the sidewalls, and the liner system are enormous. Caterpillar's MSD2 mine-specific design bodies use internal shell construction with replaceable liner systems. wear-resistant steel sections bolted in place so they can be changed in the field when they reach their service limit. Haul roads themselves are engineered systems. Road construction and maintenance at a major oil sands mine is a continuous operation. Graders, large machines like the Caterpillar 16M with its 7.3-meter blade, make multiple passes per shift to maintain crossfall drainage, repair rutting from heavy tire loads, and ensure the road surface meets the rolling resistance and grade specifications that haul truck cycle times depend on. A degraded haul road costs real production. Rolling resistance increasing by even 1% on a loaded uphill grade adds meaningfully to fuel consumption and cycle time across every truck in the fleet. The trucks, the roads, and the conditions are one interconnected system. Operating a 400-ton mining truck is not a task for an untrained driver. Haul truck operators at Canadian mines undergo qualification processes that typically begin with smaller auxiliary vehicles and progress through light-duty trucks, articulated dump trucks, and then rigid haul trucks of increasing size before reaching the ultra-class tier. Inside a 797F cab, the seat is air-suspended, heated, and ventilated. The operator's view forward is high. The cab sits nearly 6 meters above the mine floor. But the view behind is limited. The CAT Detect system, standard on the 797F, uses radar and camera arrays to create a 360-degree hazard monitoring system, alerting the operator to objects or people within the machine's immediate vicinity. Shift length is typically 12 hours. Operators manage fatigue over that time. The driver safety system available on the 797F uses camera-based eye tracking to alert the operator if drowsiness or distraction is detected. The most demanding moment of any haul truck shift is the descent. A fully loaded 797F descending a mine grade at 60 kilometers per hour represents an enormous amount of kinetic energy. The automatic retarding control manages descent speed automatically, but the operator must understand the system, anticipate transitions, and respond to road surface changes that the system cannot. They are not simply driving a very large vehicle, they are managing a system, and the mine's entire production depends on how well they do it. By the time the 797F that started this story reaches the dump point, tips its load, and returns to the loading position, the shovel will have been waiting for no more than 2 minutes. That efficiency is not an accident. It is the product of every engineering decision in the machine, every training hour logged by the operator, every grader pass on the haul road, and every data point logged by the payload meter system. The broader consequence of these machines is visible in Canada's production numbers. Canadian mining operations produce iron ore, coal, copper, nickel, gold, and oil sands bitumen at a scale that makes Canada one of the world's largest mineral exporters. The ultra-class haul truck is the single piece of equipment that makes that scale possible, moving material in volumes that no smaller machine can replicate at competitive cost per ton. The long-term impact extends beyond the mine. The tires that wear out every 6,000 to 10,000 hours feed a global specialty tire market. The bodyliner systems require specialized alloy steel. The fuel, a 797F burns approximately 250 to 350 liters of diesel per operating hour at full load, sustains infrastructure supply chains across entire regions. And the modern relevance is this. Both Caterpillar and Komatsu are now developing the next generation of these machines with battery electric and hydrogen fuel cell drivetrains. The load capacity will not decrease. The cycle times will not lengthen. But the fuel source will change, and the haul truck will remain at the center of every Canadian mine that operates for decades to come. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.